What's actually happening when I type a question into ChatGPT or Claude?
Holy crap. That's a hard one, dude. No, yeah. So what happens basically? All right. So you type into your computer, go boop, 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 like help me find new treats for my dog or whatever, right? The first thing that happens is it gets sent to a server somewhere, right? Something that's owned by ChatGPT or Claude. And the very first thing that happens is it basically takes your input, and Chat and Claude behind the scenes will say, okay, well, all right, Pierce is asking about dog treats for his dog. Let's actually rewrite that because that isn't necessarily the right way to ask that question. Okay. So it'll actually rewrite your question for you because
Like that was a dumb question.
maybe you had some spelling mistakes, right? Maybe you didn't like put a question mark. So it'll basically say, no worries, Pierce. We'll just rewrite your question. And then there's this other process where it'll take your new rewritten question and add to it the system prompt that Claude or Chat has written. So the system prompt is basically this like maybe 10-page document that contains all of the things that the model should do and the things that the model shouldn't do. So it'll start off and probably say, hey, like you are a helpful assistant. Whenever you get a question, try to answer to the best of your abilities. Feel free to use the internet. If you get stumped, feel free to do this, feel free to do that, blah, 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 right? So it'll prepend that, and then it'll say, okay, this is the question, and they'll insert the question that it rewrote for you. Then it sends that to basically this compute cluster.
The GPUs.
To the GPUs.
They're stealing all our water.
And you can think about this almost as like once you have the system prompt and the question, that's almost like this little folder that gets sent to the compute cluster, right? Along with your folder, there'll be 10,000 other questions that have come in maybe in the last 5 seconds or something like that. So then there's metaphorically a guy who looks through these 10,000 questions and say, okay, well, which of these 10,000 are from high priority users, right? So let me filter out those 500. So let's say that you paid for the pro tier. So you might get filtered out first, right? And then it'll say, okay, well, so Pierce's question is pretty short, actually. Let's actually move that up in the queue because we have this other guy, Richard, who asked this coding problem. And that question seems to be much harder. So let's just serve Pierce quickly because we know we can get this question pretty fast. So it'll move that then within the queue of priority questions, it'll move that to the very top. And then it'll say, okay, are we ready for a GPU? Are we ready for compute? Maybe there'll be one compute node that says, hey, I'm ready. Send me the next batch. And then what will happen is basically from these, top 100 questions, the top priority ones, we'll take maybe the top 20 and send those to the GPU to quickly process those. So that's where it actually gets sent to the model. So then the model sees all 20 questions, yours and 19 other random people's questions. It'll answer all of those, return those to you. And then, the guy who sent the 20 questions, this process, will look at them and say, okay, well, which questions have been fully answered, or do we need to do another pass over these? Your question maybe was pretty simple. So it says, okay, well, actually, it looks like Pierce's question got answered this time around. So let me just send that back to Pierce. And then it sends that back to the server, and then that basically gets sent back to you. Maybe some of the remaining 19 questions that got sent to the GPU weren't answered on the first pass, right? Maybe you need to do another set of reasoning or something like that over the question. Those then go to the back of the queue, and that process basically just continues on and on and on.
Until finally the front end says, hey, this is totally done.
This is done. Here's the answer.
I feel like the thing that most people don't know about this whole pipeline is that when you're actually looking at the GPT UI online, it will show you each word being generated successively. So if you have a really long response,
yeah,
maybe it'll generate the first sentence and the second one or whatever. That's actually not a UI quirk or making it feel like it's writing, but doing something behind the scenes. The models are literally generating auto-regressively. So each token in sequence at a time, and then those are getting streamed back to the front end. So it's not just a visual treatment, although they've certainly made it pretty on the front end. It's actually the model itself kind of types how we do, which is one word at a time, at a time, at a time.
That's not fully true. So there's a speculative decoding thing. So the idea is that the model is actually predicting what the next 5 tokens will be at once, right? So I'm about to say a word, maybe, right? You're predicting what the next thing is to follow, but the model is actually predicting after I say that, what are the 5 things that are most likely to come out of my mouth, right? And so it'll actually predict things in chunks of 5 or 10. And then it'll do another pass where it says, okay, well, now let me validate whether this was a correct thing to say as a whole, whether these 10 words actually make sense jointly, right? So the model is doing this weird kind of almost one word at a time, but actually chunks of 10 at a time,
sure,
and then sending it to you. And what you then see on your screen when it looks like it's generating one word at a time, that is a little bit of UI specialness that they add on top. But yeah, I mean, the point stands that like roughly the model is doing one word at a time. It's doing all these extra bells and whistles, and then Chat and Claude are adding additional like front end things to not have you be bored and sitting there for too long.
100%.
Yeah.
One thing to add on this, because just I think it's kind of fun, is when you use to search for flights online, like Expedia or whatever, you know that loading bar that it would give you to say, hey, it's going to take like 2 minutes to find the best possible flights. That all actually was fully just UI flair. There was no reason in the back end why they needed to do that. They had instantaneous results, but they found via user testing that users who were using the like early internet back in 95, 99 were like, well, we don't possibly believe that you actually found us the best flights instantaneously. We're actually going to trust
we
these more
expect there to be if there's a little bit of wait.
Yeah, that's exactly right.
Exactly.
So like, ironically, we've actually kind of ended up in chat systems like this, feeding into this loop that we're more confident when things take a little bit longer and are not just instantaneous.
Yeah, 100%. All right, Pierce, next question for you. All right. What are the differences between all these AI models like GPT, Claude, Gemini, Llama?
I think at the end of the day, all of these models architecturally are basically doing the same thing. Like they are transformer models and they're usually a mixture of experts, at least once the model has gone to a certain size. I think what people maybe aren't aware of is the fact that what makes some models different is the data that they have access to and then these RL environments that they're trained on. At this point, basically all models have just read the entire internet. Like every page that has ever been created, every YouTube video that has ever been recorded and uploaded, it might read the transcript. It has learned the whole internet. That is this phase of pre-training, which is incidentally why our podcast has the name that it does. And post-training is where most of these companies spend all of their budget and all of their efforts. Because what you can kind of do now is you can say, I'm going to define a puzzle. I'm going to define some environment that this agent or the system can interact with. Maybe that's literally just a terminal. So it can like go in there. It can enter in commands like I want to see the files in this current folder, or I want to create this new file and then execute it as some Python script. All of those RL environments that you curate, those themselves are then just executed by the model once it has seen the whole internet. And it starts off very bad at all of those task definitions. But if you throw enough compute, enough GPUs at it, it kind of like self-evolves and self-learns how to do these tasks really well. And I think increasingly, that is like the proprietary secret sauce that separates a ChatGPT from a Claude. It's just that they've built up over the last 2 years all of these different RL environments or RL gyms that their models can play within. And much like a real gym, they've gotten very buff at doing these specific things.
The one thing that people have to understand is that there's the model itself. There's GPT, there's Claude, there's Gemini, there's Llama, and then there's the harness around it, which is ChatGPT, Claude Code, right? And these things aren't actually the same thing. So there's the model that these companies create, and then around the model, they'll basically add all these additional features and functionality to it. So they'll say, okay, well, we trained a model that is good at both, video and images. And as part of that, we'll then add a sort of this functionality that allows users to generate videos, right? That functionality that lets you take this model, which inherently understands images, and then convert that into a model that can generate videos for you. That is part of the harness in some sense, right? All these base models are fairly similar. What these companies have done is added all these additional sort of tooling around these models. And that's what causes there to be more of a differentiator than there maybe should be, right? That's why, for me, sometimes Claude Code is actually a much better design buddy than Chat Codex, for instance, right? Because they've added some additional tooling around Claude Code that lets it be a better designer for like front end stuff. It's just my own personal experience.
Totally.
Yeah.
All right, Rich, moving on to the next question. Why do AI models sometimes so confidently make things up? So I guess that this is talking about kind of the hallucination.
The hallucination problem, yeah. I mean, look, AI models don't have a notion of what is truth in the world. They're just pattern recognition machines, And so if they see that things in the training data set tend to occur together frequently, like for instance, that coffee and mug and tea tend to occur in similar contexts, they'll associate those things as being similar things broadly, right? And that's all they know. Like they don't really deeply understand how these things are connected in some deep way, right? Humans do have this understanding, right? I think humans genuinely do have a deeper understanding of how concepts are linked, in part because of how our brains are wired. Language models are just pattern matchers. That's all they are. And because they've been trained on so much data, they tend to fool us really well. But in reality, they don't have a deep understanding of how the world works. We do, right? And so that's why to us it can seem so confusing when we're interacting with this thing that seems so smart and that'll just say something so nonsensical. But it's because, again, like these things are just trained to repeat things that they've seen often in their training data set. They're not deeply reasoning about things. And that is just like the core, that is at the core of how language models are trained.
Yeah. I mean, it's kind of like the root of what I really respect about people that are often some of the most intelligent people I know, where they know what they don't know. They like have a very well calibrated sense of here is their area of expertise. Any question in that area they can field. Things that are outside their core area, they actually know enough about the complexities of that area to not even want to answer it. You know, I think this is most common with professors. Where like, even if they could probably give a pretty compelling answer, they're like, look, man, like I haven't spent enough time in that area. Like I'm going to field this off to one of my colleagues. Yeah. ML models and like how we train them especially aren't really incentivized to say like, hey, I'm not sure. Like in part, they've been trained on all of this very confident text that you find online. Like when's the last time you were browsing Reddit and there's a ton of nuance, right? And people being like, oh, I'm not sure. It's like, we've literally given it like textbooks and online forums where people are maybe overly confident in their points of view. And we're like, hey, this is the best representation of English that we have. Mirror this. In some ways, it's like no surprise that the model is going to be confident. The other thing too is like, we've literally rewarded these systems for giving some answer or giving like partial credit versus it can't get any credit if it just doesn't answer the thing in the first place, right? So I think like through the evolution of these different models as they've been trained on more things, I've sensed them getting a lot better at the hallucination problem. Like I think we now kind of have these RL environments that penalize things that overly hallucinate or like say wrong things. But the question of like, you know, what is a fact? What is not a fact? What does it mean to know something? What does it mean to not know something? Are themselves very philosophical questions.
It's true.
And I don't think that, you know, the great researchers at Anthropic or OpenAI are like singularly able to answer some of those things. Some of them are just like deep truths about knowledge or like deep questions maybe that are still unresolved.
It's also this like deep like epistemological question of like, how confident are you that something is true, right? I think humans are pretty good at reasoning about this, or at least I think we can introspect in some sense about how true we think something is. So for instance, you know, if you tell me, hey, Rich, I just brewed you a cup of coffee, right? I'm like maybe 90% confident that I know what this thing is going to look like, right? That it's going to be like, if I touch the cup, it'll be hot, right? And that I know roughly how it'll smell like. I have these like deep understandings of what you're trying to convey to me. Language models have none of that. Like it's for them hard to infer how likely something is just from text and data, right? And so even when you're typing something in, there's not this like sort of like deep reasoning about how likely something is to be the case just based off of the text, right? And this comes up a lot. For instance, language models historically were really bad at telling apart like sarcasm from not sarcasm, right? Like if you tell me like, hey, yeah, totally, Rich, I definitely brewed you a cup of coffee. All of a sudden, my probability that you brewed me a cup of coffee and that if you hand me this mug, it'll be warm is maybe like 1%, right? And again, that's because of all of these, our ability to introspect, to think about what the other person is thinking about. That is something that is still innately human. And language models, by their nature, just don't have this built into how they're trained.
At least not yet.
Not yet. It's true. All right, Pierce. What's a real example of AI going wrong that we should learn from?
Oh man, this is a tough one. I mean, I think my own personal bias about where the use of AI is so annoying in practice is when people pass off the work of AI systems as their own and almost take them as ground truth, right? So there was this famous court case in New York where these attorneys submitted briefs to the court that were basically fully written by ChatGPT. And they were quite compelling. They were like long briefs, like maybe, 30, 100 pages of all of this past case law, made their client look really good, yada, yada, yada. When the court actually investigated the citations that were part of that argument, because when you're arguing a court case, you're really not trying to argue things on the merits. You're trying to apply past court cases to the new thing. Like the whole world of precedent is saying, how can we fangle or maneuver this current situation that we're dealing in into something that the court has already decided upon? Because if they've already decided on it, there's some fancy Latin name for doing this, but if they've already decided on it, that means that they have to rule in your favor, right?
Sure.
So what they found basically is like ChatGPT was making up all of these cases that, if they existed, would have been super useful precedent
that's
for
crazy.
the current
Yep.
case,
Yep.
but they didn't exist. Therefore, they're not useful in this case at all, right? And I think it ended
It was
up
trying to
either-
retrofit, like, how can I make
Exactly.
this correct?
Yes,
yeah.
exactly.
So I'm just going to make up these cases.
100%. So, and you know, that gets to the hallucination problem. This was a few years ago now. So I feel like the current generation of systems probably would not be as likely by default to fall in this trap, but it happened. And I feel like that is a very emblematic case of these AI failure modes, where if you don't sanity check the outputs that it gives you, even the like minutia of things, even the 1%, maybe the hinge element of your argument could be wrong. And if that falls down, it's all just a deck of cards on top of
Totally.
it. There's definitely this tension of like, because we've trained AI models to give us, you know, statistically accurate English, it's going to give you an argument that sounds so innately compelling. Like, that's what we've rewarded these things to do. And I think because of that, we've almost just gone more and more nuanced edge cases of like, these things actually aren't true, but you've got to scrutinize arguments with like such a fine-tooth comb before you even figure out what those are.
Yeah.
So I feel like that's one example. I feel like there's also an emerging class of scams of people using, you know, deep fakes or photos to like catfish people via text message and then steal people's finances. That's not good. There's this one case I think that happened maybe a year ago now of this Hong Kong employee who ended up wiring this scammer $25 million because they deep faked his employee. You know, it's like
$25 million.
$25 million.
That's crazy. Wow.
But you know, on some level, dog, like if I call you up
sure.
and I'm like, hey man,
Hey, give me $25 million.
give me 25 million.
We do that all the time.
I look like me. That's what I
Totally.
mean. That's what I mean. It's a very understandable problem.
By the way, you still owe me those 15 million.
I know.
From the other day.
Venmo me.
We'll do. All right, Pierce. What's the actual difference between the free and paid versions besides speeds for some of these AI platforms? So think about like, the free version of ChatGPT versus the pro version. Is it worth paying subscriptions? If so, why?
Yeah, good question. I'd say the obvious thing would be the capacity that you have for each of these models. Like usually how they price these different tiers is by the usage that you can have for them. So, you know, if the free plan lets you do 10 messages a day, the cheaper paid plan might be 1,000 messages a day, and the, you know, top tier plan might be 10,000 messages a day. And like that is kind of different between like what you do. Like if you're just on the chat interface online, you can probably use a cheaper plan. That doesn't matter that much. If you're doing like agentic work on these local systems like Claude Cowork, Claude Code, Codex, you almost need one of the bigger plans just because you like loop these things so frequently that you end up using that many more tokens. I think for me though, the chasm that we're seeing emerge is that people have very different expectations for what the model quality is based on what plan they subscribe to. Like I was in Vancouver this weekend and I was overhearing this conversation between some colleagues that were like, you know, AI systems are like so garbage. Like they hallucinate all the time and like yada, yada, yada. And eventually one of them says, yeah, you know, like I've been thinking of trying like the paid version, but like I'm right now on the free tier, right? I think you've like almost got this expectation setting that has happened in practice of most people who like don't work in tech, don't work in like the bubble of San Francisco and New York, are basically interacting with ChatGPT via either the free plan or via like the lowest tier paid plan.
And you feel like the pros are like doing something way better. Like they have access to the better models.
Well, I think it's just categorically true that if you like do pay for these plans and you pay more, you have access to better models. Like, you know, instead of a 30 billion parameter model, you have access to like a 10 trillion parameter model. And the intelligence difference of the free version of ChatGPT and like 5.6 Pro, which we use to code every day, is like talking to a PhD versus like an elementary schooler.
That's so interesting,
you know
to
what
me
I mean?
because it's one of these things where all of our friends have a paid version of these models, right? Anyone who works in tech, in some sense, doesn't really have the experience of using the free versions of these models, right? And so a lot of the criticisms that we'll have are these like very like niche sort of nuanced criticisms of, oh, like this model is now being served on this chip, which is faster. I can't believe Claude isn't doing that, right? But the reality is that most of the world is using the free version of chat, especially, right? So ChatGPT, more so than Claude, is dominating the market amongst just, you know, consumers like you and I. it's almost like this two-tiered system, right? Where it's like the paid subscription model and the unpaid subscription model. And I wonder if these two things are going to keep diverging more and more and more, right? Where if you're paying for the model, you actually don't even know how, in some sense, like bad the model experience is if you're not paying for it, right? You just kind of take it for granted. It's interesting that you mentioned this because I kind of almost assume that the models, when they hallucinate, it's because there's something fundamentally wrong with the model itself. But if you're on a free tier, you maybe just don't know if it's because you're not getting the best model, right, to begin with.
This is what I've been telling everybody. For 1 month, set aside in your budget $200 and use one of the paid plans of Claude or ChatGPT. I think if you want to be interacting in like the modern economy, I think it's so important to have a point of view on how good these models are. And the only way to know how good these models actually are
is to test it out.
is to test them out yourself
Yep.
on your own challenges in like your workplace or your personal life or whatever. And to do that and get a good calibration, you'll want to use the best quality model, which for right now is like 5.5 on ChatGPT and I guess Fable when you're working with it. So put the $200, do that, calibrate for yourself, and like that's the only way that you can tell.
Yeah, test it out.
Test it out.